Hello friends, so today we are going to discuss about the topic Introduction to Embedded System and Microcontrollers. So before we going through with the concept of Node MCU ESP8266, we need to understand about the embedded system and microcontroller because Node MCU is a type of microcontroller. So to understand it more briefly, we need to understand the concept of embedded system and microcontrollers. Embedded system and microcontroller are the unsung heroes of our modern world, quietly powering countless electronic devices that we rely on daily life. These two terms, often used interchangeably, refer to the essential components that is responsible for controlling and managing the wide range of devices from any area, any place, for household appliances to complex industrial machinery. So, I would like to take you on a journey into the fascinating world of embedded system and microcontrollers, two pillars of modern technology that quietly shape our daily lives. So, moving to the next part, table of contents. The topic which we are going to cover in our presentation is introduction, choosing a right programming environment, installing USB to serial drivers, installing the development platform, selecting the board and port, installing libraries and add-on, and testing your setup. So all these topics which we are going to cover in our presentation today. Defining introduction to embedded system. Here is a flowchart diagram, um, understanding about the analog components, digital components, software converters. These are the different parts of embedded system. So before we going through with that part, we need to understand about the embedded system. Let's define what embedded system is. It's a dedicated computing system designed to perform a specific task or a function within a larger system. Unlike general purpose computer, which are versatile and capable of running a wide range of applications, embedded systems are tailored to perform predefined functions efficiently and reliably. Embedded systems are all around us, often hidden from view. They power our smartphone, control our home alliances, manage traffic lights, regulate our car engines, and even monitor our health through medical devices. In essence, they make our world function seamlessly. Microcontrollers, when we talk about the microcontrollers, they are the heart of embedded system. A microcontroller is a compact integrated circuit that contain a processor, core memory, input output peripherals, and sometimes even communication interfaces all in a single package. Key characteristics of microcontroller, that is low power, real time operation, compact size, cost effective. These are the key compacts of embedded system. Embedded system, let's take a few example of a car engine, control ECU unit, optimize fuel injection for efficiency and emission control. Smart thermostat regulate your home temperature. Medical devices continuously monitor vital signs, enabling better patient care. So, there are so many challenges programming environment for embedded system. So many softwares have been used for embedded system. The digital components are there. Some converters are there to convert that different signals and transmission into a proper manner. So basically, embedded system and microcontrollers may not always be visible, but they are the silent heroes behind countless technological advancements. They enhance our lives, streamline industry, and push the boundaries of innovation. Like it's a popular choice among electronics enthusiasts and IoT developers due to its combination of ESP8266 Wi-Fi module and a microcontroller unit. It's a compact board empowers you to create a connected devices. Like we want to connect to a, it's just an example. Node MCU ESP8266 is an example of a popular choice of a microcontroller. It's a compact board you to create a connected devices, gather sensor data, and however, like when you are creating any project, it is essential to develop a solid development environment. It's very important to create a solid development environment when you are creating something. Choosing a programming environment. That's a very important part. It's uh, it's a crucial decision that can significantly impact your development process. like defining your requirements. Start by defining your requirements. Here is an example of the different kind of coding languages and operating system we are using under embedded system programming. See, when we come to the fact like choosing a programming environment, it can be anything. Like when we communicate with each other, we using a common language, English or Hindi, to talk to each other, students. So it's the same thing with our system also. We need to have a specific programming language that help us to interact with the devices in a very efficient manner. It helps us to design the system in a very effective manner we want, depending on. So the languages, there are different kind of programming languages that we are using in our embedded system. We have to understand that requirements and we have to go through with it. Like we have to understand the microcontroller model. We have to understand the hardware interfaces, the real-time requirements, and community and support. Considering the language that C, C++, MicroPython, RTOS framework, these are different. The choice of programming language can significantly influence your environment. C++ embedded systems are programmed due to their efficiency and low-level control. They can be included in Arduino IDE for Arduino boards or a platform IO for various microcontroller. Microcontroller with more resources, MicroPython provides a Python-based environment, and C Sharp, it's a .NET based framework that you can program extended and external libraries like Python for it, and Lua scripting language you can use on that. So these are the some of the programming languages, coding languages that can be used in embedded system programming. Coming to the next thing, um, it's about the same thing which I have discussed with you, that choosing the right programming language according to your choice. It's very important to understand the programming language of your choice, because it is the only way to communicate with your devices if you choose a right programming language. It's a crucial decision actually. So you have to experiment with the different environments and find the best that suits your project. Installing USB to serial drivers. Installing USB to serial driver for Node MCU ESP8266, it's a crucial step when you want to program or communicate with your Node MCU board via USB. Like plug in your Node MCU. Here's an example of Node MCU ESP8266 serial development board is given. Some of the tantalum capacitor of two different ohms are given. Blue LED light have been given of 0603. Voltage have been given, how much power supply you can apply on it, 3.3 volt LDO regulator, CP2102 USB to UART bridge, and start plugging by your Node MCU USB to boards into an available USB port on your computer. Check device manager or the system information, like which kind of system you are using, whether it is Windows or Mac OS. Open the device manager, pressing Window key and selecting the device manager. Look for a device with an unrecognized driver. macOS, open the system information app. You using the hardware section in the sidebar, select USB. Look for the Node MCU USB to 66 port in the USB device tree. Download the appropriate driver. Like it's a basic step that you need to perform, like selecting the Node MCU USB to 66 port, then selecting whether that CH340 driver for an operating system, whether that CP210. These are the different drivers which I'm telling you. You can select through that Silicon Lab website and select the drivers of your choice according to the project requirement. Installing the drivers. Run the driver installer you needed in the previous step. Verify the installation, whether that installation is complete or not. Check the device manager or a system information again. Your Node MCUSP 266 should not appear without errors, usually under the ports com. Select the COM port or serial port in your ID when you are programming your Node MCU. Use an integrated development environment like the Arduino IDE and select the appropriate COM port or a serial port that correspond to your Node MCU board. So it's a successful install the USB to serial driver for your Node MCU ESP8266 port, and it should now be ready for programming and communication with your computer after uploading the code at Node MCU. So these are the some basic steps that we perform installing the development platform for our Node MCU. So, in our next presentation, we will be discussing further about how the next procedure after installing the development platform for NodeMCU. Thank you, guys, and all the best.